Welcome to our organic chemistry practical work. We are second year students in applied physics from the IUT of Blois. We are Audrey and Fanny, and we are going to show you how to synthesize aspirin in a lab. Aspirin is an anti-inflammatory drug used for medical purposes.
Before everything else, let's talk about safety. In a chemistry lab, it is required to wear a lab coat, gloves and eye protection when manipulating chemical compounds. Now we can start.
To synthesize aspirin, we use salicylic acid, acetic anhydride, concentrated sulfuric acid, distilled water, and 95% ethanol. First, we weighted 7 grams of salicylic acid in a small container.
Then we introduced into a 2050 milliliters ground neck elamer the salicylic acid. We added in the same elamer 6 milliliters of acetic anhydride under the hood. Then we added 4 drops of concentrated sulfuric acid.
After, we heated the enlamer at 60-70 degrees Celsius to dissolve the aspirin. We put a magnet into it to stir the solution during the reaction. We hung the container to a refrigerant connected to tap water when we heated it in order to collect the steam.
We added 50 milliliters of cold water to stop the reaction. The aspirin isn't soluble in cold water, so the crystal precipitate. We stirred the solution and put it in ice fast because the aspirin precipitates faster.
Secondly, to collect the aspirin, we filtered the crystals with a Buchner. The result is a powder. We could think it's aspirin, in reality it's not. The crude aspirin obtained is not pure. To wash off the impurities, we poured 10 milliliters of 95% ethanol.
We placed the beaker in a water bath at 80 degrees Celsius. When the crystals were completely dissolved, we poured 10 milliliters of hot water. We cooled it again to obtain purified crystals. We filter it again with a Buchner to collect the crystals. There was still water in the aspirin. We weighted the powder before putting the aspirin in a furnace at 90 degrees Celsius to have dry powder.
After 24 hours, we weighted the dry powder to compute the yield, and then we compared to the yield obtained the day before.
Finally, to check the purity of the aspirin, we use a coffee bench. We compare the melting temperature found with the one from the booth. The closer the temperatures are, the purer is the product. The aspirin synthesized during the lab work, the temperature was exactly the same as the theoretical melting temperature.